Have you ever heard of continuous testing and then thought to yourself, what is continuous testing? Today we are going to talk about just that. Why in the first place was continuous testing designed? And then how generally people define continuous testing? Why do you need continuous testing for your product? We are perfectly fine doing the way testing we are right now. And finally, if you do decide to do continuous testing, what would be the real basics you need to set up before venturing into continuous testing? So before we talk about continuous testing, the bug bottleneck. Now the reason I call it a bottleneck is, have you ever been in the position where the release date is just a few days ahead and the testing team has found out some one or two major issues, and the whole team is deciding between if we need to fix these issues or release with an open bug, or fix the issue and then we don't have enough time to test it? That's a pretty standard problem that testing teams or development teams come across in general, and that's what I'm calling a bug bottleneck. The story usually, the way it's narrated, is at the very last moment the testing team found issues. The reality is, most of the time these issues have been there in the system for some time, and they have been accumulating over time, and during regression, when testing is done in detail, these issues keep popping up. And now we're going to talk about how these issues pile up. So this is a typical sprint cycle through which any team would go through. And when we start off this test cycle, we are assuming that there are a few known bugs in the system, and there's a certain feature the development team is going to implement in this phase, and the few issues that have been reported would be fixed. Now when development is done with their implementation and code changes, having implemented new features, it's only natural that there would be a few issues that have been introduced while the new features have been implemented. And we're just giving an arbitrary number here to track and compare the results. And not only would we have issues directly related to the new feature, we would also have issues which would be ripple effects from the changes that have been done. For instance, an unexpected change which might be affecting another area of the application which the developer did not foresee. And we are calling these regression bugs, and again we have few of them as well. And the old bugs have been fixed. Now with this status, we move on to the testing part of the sprint. Now the testing team would have a number of one or two features, or as many were planned. So they have to go through the feature and they have to understand the feature. They have to test the feature itself. Then they have to do regression around that feature, and that would be just one item. And if you have multiple items or multiple stories, then it does get challenging for the tester to have adequate amount of testing against each specific item, because they have to test the item itself and they have to do regression around that item, which takes time. Now between the two, they would obviously be dividing their time between new feature testing and regression, or whatever regression around that feature
So because of this division of attention, we are saying that only a few number of bugs were captured, and we're saying 40% of the issues in the new feature set were not captured because they were they didn't have complete focus on testing just new feature bugs. About regression, now mind you, we're talking about a complex and large application here, and usually products which have a very huge feature set, it's really hard to go through regression and even touch the main areas around regression for such applications manually. It's just too much. So we're assuming at this point that probably they might not be able to get enough regression bugs here, which is why the count of bugs that have been reported here are 0, and the remaining of these issues go undetected through this sprint. So we have 5 regression bugs which went undetected and two of the new feature bugs. Now these numbers are arbitrary numbers, and obviously they don't have any rationale directly associated to them, but in essence what we're just trying to explain here is that due to the amount of testing that has to be done and the amount of resources we have with time that's available, it's not possible to test adequately the whole application or the amount of testing we need just by doing manual testing and just during this testing cycle. It's only inevitable that some features would not be tested. Now we move on to the next sprint, and we start this one with 7 unknown bugs from the previous sprint, 3 known ones which were reported. The development team fixes the 3 bugs that were reported to them, and the unknown bugs are well unknown, so no one knows they exist. And we again have some new features implemented, and which introduce new feature bugs and again some regression bugs. We move on to the testing cycle again, and again, as from the previous one, we do capture some feature bugs, but the regression ones, because we are not able to do regression enough or nothing at all, so we don't capture anything, and the unknown bugs add up to 14 issues from 7, and this keeps building on in the third cycle as well. So you can imagine by the time regression reaches, there are a lot of issues in the system already which have just passed undetected, and as soon as regression hits and the testing team dives deep into the areas that were affected around the change in detail, these issues start to come up, and no wonder near to the release date we have these problems, because these issues were there all along. We just weren't able to get there in time. So now we talk about what continuous testing is and how is it generally defined. Now, as the name suggests, continuous testing is about testing throughout this development life cycle and not just testing during the testing phase only, which is generally how testing is performed. So in this example here, so right after the sprint planning, when we go into development of our feature set, we run the automation scripts side by side, and that's as soon as a developer implements something and checks in their code, the relevant automation scripts are supposed to fire off and give the developer a quick feedback as to if the general or very basic core areas of that certain revolving around that feature set are working fine or not. For instance, if the developer has done some changes in module A, then any tests any basic tests around module A should fire off and within few hours give feedback to the developer as to how, if they are passing or failing. This way, if there is a major issue, the developer can do the fix right away and then check in, instead of checking in and pushing something to QA which has obvious problems. Now similarly, when the testing cycles begins, the testers do not have time, again as we talked earlier, to go through a complete regression, and so that's where automation would come in, and they can leverage the automation scripts and plan their testing keeping in mind the results coming out from the automation results. So an automation script would fire off, or a batch would fire off with feature sets depending on how big the feature sets are and how much time we have. Automation can run all the relevant scripts, and the testers can view the results and have an idea as to this area is passing, so, and they can have some sense of shall we say confidence as to on certain areas of the application how they are behaving, and they can focus more on how the new feature has been implemented, and think about scenarios which are not in the scripts. So that's generally how a very vague definition some people would describe continuous testing is. So in essence, testing is being performed throughout development, while development is going on, while testing is going on, and in this way we are not leaving regression or in-depth testing of the application just for the end and then finding issues. So we keep on testing in depth. Another important area of continuous testing is it's not just about testing, it's also about the feedback loop that's going on. So the tests have to evolve, the automation scripts have to evolve, the general process has to evolve, and for that you keep getting feedback from different aspects or different teams or different departments working with the product. For instance, as soon as we test the feature set and it's being released and deployed, now the support is going to, they would get issues from the field and have an idea of what worked and what did not work. Sales teams, they would have an idea of when they are selling, what customers are asking for, that sort of thing. All of this feedback needs to get back to the testing and automation team so that they can improve their tests and add more focus on areas which are more important, and perhaps shift their focus from areas which are lesser important and more energy and resources are being spent there. And that's how you make your testing more intelligent, because at the end of the day we won't be able to test the whole application, so we need to find out which areas are more important and need to just test them only. Now we did talk about why do we need continuous testing. So continuous testing is the next step, and it's all good, but how do we get there? What would be the basic requirements? Now, since this is an evolving subject and a lot of people have different takes on this, and there is a very long list of what you would need in order to reach continuous testing or have continuous testing executed effectively for your product. The list I have is one of the very few basics that I started off with in one of our products that we worked with. So the first and most important item or aspect for continuous testing as a requirement would be to increase your test coverage. Obviously, we are expecting automation to have a good test coverage for our product, then only can we rely on it for regression. And for complex and huge applications, getting to a decent coverage percentage can be challenging. And to reach there, these are some of the areas you might need to look into for functional tests. Obviously, UI level tests have to be there. API tests would allow you to increase coverage quickly, and they would be less costly in execution and developing them and maintaining them, of course. Depending on the type of application, security and performance would be important. Mobile platform, if you do have mobile solutions, and unit tests would definitely be an important area as well. So these are just a few pointers, and there are a lot of areas where you can look into further to increase your test coverage, but the whole idea is that you have a mechanism where you can increase your test coverage to a very reasonable level. Then only can you rely on your automated tests. Now, you can run any number of tests or script just some scenarios and execute them in a loop, but that does not mean that they are meaningful or they are helpful. The tests are supposed to give important feedback to the developers and to the manual testers as to what's going on with the application's features and how they are performing. So the first aspect here would be the test cases that are needed by a developer, for instance, are supposed to be there. So if module A is being updated, so certain tests, certain basic tests, they would expect to be there in order for them to have a reasonable feedback if this is working. Similarly, for a tester, they would expect basic feature sets and some use cases which are common should be part of the automation batch process. Then only can they rely on these tests. Also, it's important to get the results when they are needed. Now, for instance, a developer does add a change to the code and they check it in, and if the automation is sending or giving feedback after 1 week or something, that feedback becomes irrelevant because by that time the change that the developer did is not fresh in their mind. They've moved on to do other stuff, and it would take them time to go get back in the frame of mind needed to debug that issue and fix it. So instead of getting it weeks or days after, that result the developer should have it within a few hours so that they can look at it before they are sure that they have done their job properly. Similarly, for a tester, before they start their testing, they should have the automation results, giving them an idea of what areas are passing, what's failing, what tests have been done, so that they can plan their testing according to what areas automation has done already and just try to fill in the loopholes which have been left. And that would make the results meaningful. Test your code before checking it in. Generally, the development team is swamped with items. They don't usually, in a typical team, would have enough time to, or have planned enough time to test their changes in detail on their own. So they need automation to do that for them. And before checking in, the tests should run and the results from those tests should be taken into consideration. if we do check in areas which the automation is spitting out failures on, the developer checks in, it goes on to QA, the testing team finds those issues, then they log them into Jira or whatever bug tracking tool we have. As per the priorities, the ticket eventually reaches the developer again after a few days, and then they have to fix it. So the fix would have to be done sooner or later. If it's done later in the life cycle, so how many people got affected through this? The tester spends time, the developer spends time, the tester spends time finding it, reporting it, adding to Jira. The developer again, goes through Jira items and then deciphers it, gets into the frame of mind of fixing it, does the fix, patches it over. The QA guy again tests the fix and then closes the item. So there's a lot of time that's being spent there. So the wisest thing to do is to not allow Jira items being created in the first place and avoid that part instead of adding tickets and then trying to fix them. And once you do have continuous testing, the manual testing team can have the leverage of using these results and try to test quickly. Areas that they feel are missing in the automation, they can keep them adding to the automation scripts and improve them and focus on new features and new areas. And this should reduce the testing cycle, and that's what we are talking about. Time to market. We need a shorter time to market. From the time we decide we need to implement this feature till the time it gets into the customer's hands with quality has to reduce. The final requirement which I'm making here is collaboration, and that is truly the essence of Agile. But in order for continuous testing to work, this is vital, this is important, because any team writing scripts in isolation would have absolutely no benefit for the developer or the tester or for the end customer by the end of the day. So development needs to give input what tests, how they are using the reports. Testers need to give them input as to what areas they should look for when they are developing and when they are going through the automation results. Manual testing teams need to figure out what information they need in the automation reports, how to use them, what tests are lacking, what to add, and most importantly, they should be getting feedback from the clients, from support team or from sales team as to how the testing is performing. For instance, when feature A was released, in release A we had 10 issues coming back. We improve our process, find out how these slipped, what we can do to prevent this. In release 2, release B, we have, if we improve on that feedback, we might have 8 issues coming back from our clients, so on and so forth. So the feedback from clients is eventually, I believe, how to gauge the testing and development is going on. If you have a lot of issues coming back from your clients, from support, something has to be fixed. If we are getting lesser number of tickets from the support or issues from our clients, then we are doing a relatively better job. So, and all of this needs collaboration between departments and those people on ground who are testing themselves, who are developing themselves, including higher management, but the actual tester and developer and support guy and sales people need to talk to one another. And that's the last point on the requirements for continuous testing. Again, this is not a conclusive list. There is a very long list of what things you need to add for continuous testing, and it's not just adding a few steps in your process, it's a complete mindset change where all teams are collaborating and talking to one another and picking up the burden from each other, and that's where the differences comes in. Thank you guys for watching, and please do add any questions or comments you might have in the comments below. We'll try to get back to you as soon as we can. Thank you and see you next time.